So today we're going to be talking about energy in capacitors, and so we're going to calculate the energy stored in a capacitor. And a charged capacitor stores electric potential energy because it requires work to move charges through a circuit to the opposite plates of a capacitor. The work done on these charges is a measure of the transfer of energy. So we have three different equations we can use to calculate the energy stored in a charged capacitor. So we have PE, which is P electric, equals 1/2 Q, which is the charge, times the voltage, or final potential difference. So this is one of the main equations that we use when we're calculating the the energy stored in a capacitor. But we can also use PE, which is also electric potential energy, equals 1/2 C, which is the capacitance, times the final potential difference squared. And we also have PE equals Q, which is the charge, squared over 2 times the capacitance. So today we're going to be using this one down here in our equation, or in our problem. So we're going to write it up here. It's PE equals 1/2 C delta V squared. And today in our problem, our problem, it tells us that the capacitance of the capacitor is 4.33498 times 10 to the negative 6 farads, which is the SI unit for capacitance. And it tells us that the voltage on the battery that this is going through is 2.12 volts. And we need to find the electric potential energy of this capacitor. And our answer, which is PE, is going to be in joules. So question mark joules. So we set our equation up, or our problem up, and it's PE equals 1/2 4.33498 times 10 to the negative 6 farads times, I'm going to write it down here, 2.12 volts squared. And if we do the math on our calculator, we can tell that the answer for PE, which is PE electric, so it's electric potential energy. So our electric potential energy going through this capacitor is 9.74156 times 10 to the negative 6 joules. And that is our electric potential energy that is going through this capacitor, which is attached to a battery of 2.12 volts. And that is how you calculate the electric potential energy going through a capacitor.